ग्रुप पर इनिशिएट के लिए जरा चेक करा Can you all see me on blackboard or the biological chemistry is Mangawa like you to Katachawa. Can you see? So far as I can see, Siddhesh Shetty आपला विचार किया का हिस्सा ही था. आता बंद करा. Okay, come out of YouTube. Okay, so good morning. This is the second offline lecture, right? And those who cannot come to the classroom because of bus strike, for those students, I have arranged a YouTube live. So like Siddhesh Shetty, some of the students can see me live on YouTube, right? And meanwhile, I can see some new faces. So I'll try to recall the names. There's Maya, there is Manoj, there is Neha. बुरके में से शायद मैं फिर से माथा जान पाऊँ तो प्रॉब्लम हो गया. बट ठीक है, मुझे जो याद है वो है कौसर, वो है नजमु सहर, वो है उमेरा और अफशा. बराबर पहचाना, बुरके वैसे ही पहचान गया मैं कि ये अलग है. So Afsha is another one. Then there is Prathamesh, and then there is Pratima, there is Pratibha, like Maya and Pooja, right? So this is what Pratisha and Duni. So Sampada, Sampada and Susampada, right? So Susampada, yes. आश्लेषा. ऍक्च्युली माझ्या माहितीप्रमाणे मराठी शब्द आश्लेष आहे, पण इट्स ओके, फाईन. तुझ्या घरच्यांनी ठरवलं की अश्लेषा म्हणायचं. ठीक, पण चेक करा मराठीत आश्लेषा नक्षत्राचं नाव. आश्लेषा नक्षत्र. Anyways, so dear friends on YouTube, yesterday we talked about Henderson Hasselbalch equation, and that is what I will be repeating today. So this is what I'm talking to my YouTube students, and I'll tell you the derivation of Henderson Hasselbalch equation is and why do we use Henderson Hasselbalch equation. The first connection of Henderson Hasselbalch equation is with pH, negative log of H plus ion concentration, or potential of hydrogen ions in a given solution. So if you can recall my earlier lectures, we had talked about the presence of hydrogen ions and hydroxyl ions in a solution that determines the pH of a solution. We talked about the pH scale from 1 to 14 and how when gradually you go down from 7 to 1, the solutions become acidic. And when you go up from 7 towards 14, the solutions become basic. We also talked when you try to increase the concentration of H plus ions in a solution, it is a kind of pressure on the system. So if you are trying to increase H plus ions in the solution, OH minus solutions concentration has to go down. Or if you are trying to increase the OH minus ion concentration, H plus ion concentration has to go down so as to keep a balance, right? That is what we saw in equilibrium. So anyways, I'm not going to describe that again today, but as we said, we will be talking about Henderson Hasselbalch. Look at the spelling scale. This is a tricky spelling that we have. Henderson Hasselbalch equation is what we will be talking again for the sake of your understanding and for the sake of understanding of students who are there on YouTube channel. I'll try to bring it closer probably so that the students can clearly watch what is happening on the board. Some disturbance, of course, due to the camera stand that I have, but nevertheless, now hopefully you can see it again. Okay, so we were talking about a situation where you have strong acids or strong bases, and another situation where you might have a weak acid and weak bases. So when we say strong acids or strong bases, that means we are talking about acids or bases which can dissociate at a higher rate. Okay? For example, hydrochloric acid, like we discussed yesterday, HCl. HCl is a strong acid, so it can dissociate very fast into its respective ions. And what are those respective ions? Hydrogen ion and chloride ion. Laksha deya, huh? So we saw this thing yesterday. HCl dissociates into H plus ion and chloride ion. Kalin सांगितलं, I do not prefer it to call it as Cl minus. Chloride ion. Be technically correct. So here you can see HCl dissociates into H plus ion and chloride ion. This is a strong acid. So strong acids dissociate quickly, dissociate only with the truth. Right? But talking about some weak acids or bases, for example, we are talking about acetic acid, IUPAC name is ethanoic acid. So when this acetic acid breaks down, dissociates, it dissociates into CH3COO minus, that is acetate ion, and H plus ion, that is hydrogen. HCl and acetic acid, they are acidic in nature because when they dissociate, they produce hydrogen ion. So both are acidic. Right? But this is a strong acid, this is a weak acid. And when we say it is a weak acid, that means it does not dissociate at a higher rate. So number of ions that it will produce will not be much. It will produce lesser amount of ions. Right? So this is one thing that you have to remember all the time. So when Henderson was trying to propose an equation for calculating pH of such solution, Henderson प्रयत्न करत होता आपण एक इक्वेशन प्रपोज करावी की जेणेकरून एका सोल्युशनचं pH आपल्याला डिटरमाइन करता येईल. He said that the dissociation constant of an acid Ka, dissociation constant of an acid Ka is equal to what? Concentration. Remember, we have correct. So concentration of product of A minus and H plus upon concentration of. This is what the YouTube people can see what is being written here. Just in case if they cannot, I will just try to do it a little closer so that they can see. So this is what Henderson is. But Hasselbalch was another chemist. And Hasselbalch said, Mr. Henderson, this is all right if you calculate the dissociation constant of acid like this, but what about weak acids? They are ions in the solution so that you can measure. When some things are in very less quantity, for example, if you are putting this छोटा सा चौक का टुकड़ा टाकला, the probability it will not even detect. Right? So either you have to make your instrument very sensitive. If the instrument खूप sensitive असलं पाहिजे, नाहीतर so in mathematics, when you have to multiply something in tens, hundreds, thousands, then you use logarithm. So you multiply negative log on either sides, on both sides, and made it negative log Ka H plus and A minus, so that it becomes easy for writing in the calculation. Negative log H plus ion concentration and minus log H plus upon, sorry, A minus upon H. Whenever I am writing something in the bracket, that means concentration, right? So concentration of H plus negative log बाजूला केला आणि negative log A minus upon HA हा बाजूला केला. The reason why it is negative here is because if you remember, when you add, when you have to find along with its log, you add it. So negative log of H plus into A minus will be log H plus plus A minus. But here minus, right? So this comes as minus log H plus minus log A minus concentration upon concentration of H. So this is concentration of acid, and you call it as conjugate base of that. So this is called as conjugate base of the acid. Simple thing that we have seen is, if you can see here on the board, this is acid. When the acid dissociates, it produces hydrogen ion and its base. So this will be the conjugate base. So this is conjugate base. Now from our previous knowledge, we know that negative log of H plus ion concentration is very good. And negative log of K is called as pKa. So now we have an equation which says that pKa is equal to pH minus log concentration of conjugate base upon its corresponding acid. Alright. Follow this, right? Now rearranging the equation, what we will get is the final equation here, and that will be, I'll just write it as pH is equal to pKa plus log concentration of corresponding conjugate base upon concentration of acid. This equation is called as Henderson Hasselbalch equation. Those on YouTube people can, if you can see clearly on your course, at least I can see clearly. YouTube, that means either they are absent or they don't know. How many have come here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 plus 2, 16. Okay. So have you understood this? Yes. Everybody has followed this. Now we'll do a little change. Like there are acids which can dissociate into their corresponding ions, similarly, there are bases also which will dissociate into their corresponding ions. जसे acid dissociate होता है, तसे bases पर dissociate होते हैं. So we will see a case of what happens to a base. Okay? In books they write it for the sake of your understanding. So understanding how. In books they write it different. So I'll drop this, shall I? YouTube people are loving it. Okay. So that Henderson Hasselbalch equation which I had written just now is gone. I hope you have noted it down your notebooks. Don't rush over. Yes, please. So student number 15 is here. You are at unit 7. You can sit here. There's a student there. So since this is YouTube live, you can watch it anytime. Go to my YouTube channel, subscribe it, and watch it anytime you want. Now imagine that instead of acid, there is a base. So for our sake of understanding, I'm writing it as BOH. Just like we wrote acid as HA, because H was hydrogen ion that was coming out, and it is acid. So similarly here B is base and OH is the uninactive. So when the base will dissociate, it will produce B plus and OH minus. So Prathamesh, if you want to correlate it with something that normally we see, NaOH will dissociate into Na plus and OH minus. Simple basic equation that we see as far as dissociation of bases is concerned. No problem in understanding that? All right. Now let us go on and see what can happen with the bases. Henderson said we will continue doing this exercise and proceed with what Hasselbalch told. So this now becomes dissociation constant of the base. So we will write it as BKB. Right? Like after dissociation of the acid, you were getting H plus ion and the conjugate base. Here you will get B plus and OH minus. B plus and OH. In the earlier, we should write it. Writing, those on YouTube, 2 people, very important. It's important that you write because even if you think that your brain has a lot of capacity to store, memory to things, but it depends. There is short-term memory, there is long-term memory, and you are all Rajni. So मैं forget after 15 minutes क्या base, क्या acid, क्या dissociation, कुछ याद नहीं आएगा. So you will recall, then you will get it. Therefore, and so you see, whatever I do every day is written in my notebook. So what I will be teaching today is also written here. The numerical problem that I am going to discuss in some time is written here. So it is important that you write. It will change. It will change. So now this will become BOH. Correct. So into its corresponding ions, its dissociation constant will be KB. And I told you the system wants to keep the sum total of the ions as same. This equation, it will try to keep everything same, like I told you yesterday. In a class of 11 students, the example I had given yesterday was in a class of 11 students, 6 passed and 5 failed. So total is 11, right? If 7 pass, how many fail? 4. If 8 pass, how many fail? So when 8 is increasing, I mean when pass number is increasing, the fail number will go, pass number will go down. Finally, the total number will remain same. So same idea, right? You understand? Right? एक आधी गोष्ट कमी झाली तर दुसरी गोष्ट वाढवावी लागते. एखादी गोष्ट वाढली तर दुसरी गोष्ट कमी करावी लागते. So that happens in the solutions also. So here, that is why this equation. Alright. So according to Hasselbalch, the Hasselbalch said the amount of ions will be less. So how you will take them? So Henderson and Hasselbalch, they came together and they said, oh, we'll take a log of it. Log is multiplied 10 times, 100 times. The log to the base 10, natural log, multiplied 10 times. Right? So again, take negative log of Kg is equal to negative log of OH minus ion concentration and negative log of concentration of conjugate acid. Base conjugate acid. Concentration of conjugate acid upon concentration of the base itself. Okay. And so you have again negative log can be written as P. So if you have PKV value and you know like pH, so you have POH. So this will be POH, where you remember that pH plus PO is equal to 40. Right? So this is POH minus negative log, minus log concentration of conjugate acid upon corresponding base. And then rearranging this, what you get OH is equal to PKV plus log of concentration of corresponding base upon concentration of its base. This is Henderson Hasselbalch equation for a base. So there are 4 people on YouTube now. That makes it 15 plus 4 is equal to. YouTube people, are you able to understand and read on Blackboard? Write in the chat box of YouTube, comment box in the YouTube. Can you all read on the Blackboard what is being written? And are you able to understand, yes or no? Siddesh, are you able to read and understand? Komal and Renuka. In the comments. Yes, Siddesh says yes. So class is on. Is this clear? So 2 parts. Now this is very, very important when you apply it to system which we call the buffer. Major understanding understanding of the Henderson Hasselbalch equation. This becomes very, very important when you apply it to buffer. Right? And how that we'll see. Before that, we'll try to do a numerical problem. We'll try to see if we can solve a problem. A very simple problem. But I do not know whether you have your mobile phones, and on your mobile phones you have scientific calculators. Big calculators on mobile. Okay, so I'll give you some time to try and solve it. It's a very easy problem. I'll write it on the blackboard, or in the meanwhile, the YouTube people also, 5 who have joined here, they will also try to do it. The equation is very simple that you have written in your notebook. So YouTube people, if you're not writing it on your notebooks, you will be definitely in trouble. So unless if you are just listening it, the right answer it will not work. You will have to write it down so that you are able to solve. So I'm rubbing this. I'm giving a numerical problem to you. The problem is I hope my handwriting is readable for all of you. A buffer solution. Now this is what we are going to discuss next after talking about this Henderson Hasselbalch equation. A buffer solution. Now, what is a buffer solution? As we'll discuss, buffer is a solution of a weak acid with its base, or a weak base with its corresponding salt. Weak acid with its corresponding salt, or weak base with its corresponding salt. I'll tell you examples later on, once we finish up doing this exercise. So the question is, a buffer solution made of 0.4 molar CH3COOH, that is acetic acid, or IUPAC, ethanoic acid. So a buffer solution made of 0.4 molar acetic acid. So you know the concentration of acetic acid in the solution. And 0.6 molar CH3COO minus, what is this? This is acetate iron. What is this? Acetate iron. So you know the concentration of the acid, and you know the concentration of acetate means its corresponding base. If you remember Henderson Hasselbalch equation now, खालच्या गोष्टीचं concentration तुम्हाला माहिती आहे, वरती दिलेलं त्याचंही concentration तुम्हाला formula मध्ये. So this is A minus and this is H2. Those values from there. I give you the third value. If the acid dissociation constant म्हणजे काय? Ka value, correct. If the acid dissociation constant of acetic acid. So in case you are not sure what this is, I will write in the bracket Ka value. So if the acid dissociation constant of acetic acid, that is Ka, is 1.8 into 10 to the power minus 3, this value is given. Right? Then the question arises, what is the pH of the buffer solution? Question mark. So far as we know today, there is a huge possibility that Pune University might conduct offline examinations. And if they ever conduct offline examinations, then there is always a possibility that such numerical problems would be asked in the examination. Even if it is an MCQ examination, then I don't mind giving you this question and giving 4 options to you asking for the correct answers. So even in MCQ, you are going to get such questions. So be ready and practice such numerical problems. We'll gradually, practice more with some more difficult numerical problems. But in the meanwhile, this is the problem. So I'm reading it again. A buffer solution made up of 0.4 molar acetic acid and 0.6 molar acetate ion concentration. If the acid dissociation constant of the acid is 1.8 into 10 to the power minus 3, what is the pH of the buffer solution? I want somebody amongst you to come here and just write down the Henderson Hasselbalch equation. Yes, please. कौशल आइए यहाँ पर बड़े अक्षरों में ताकि हमारे YouTube पे जो भाई बहन है वो देख सकें. So my dear YouTube friends, Kausar is writing the Henderson Hasselbalch equation here. Thank you very much, Kausar. एकदम बढ़िया बिल्कुल सही. So Kausar has written the Henderson Hasselbalch equation, and I do not know if it is visible to you. Yeah. So you can see here pH is equal to pKa plus log A minus concentration, that is concentration of the conjugate base, upon the concentration of the corresponding acid, that is H2. Right? So this is the formula that we have used. Simple formula. So probably you may not be able to calculate the logs, maybe with the mobile phones that you have, you might not be having scientific calculators, that's all right. But at least try to put the values. Try to put the values. Where would you put what values? YouTube people, you also can do the same. Try to put the corresponding values in the formula. And after putting the values, what is the next step that you get? So I will maybe ask somebody to come over here and write the next steps here. Who is going to come? Anybody? Yes, please. What is your name? Trupti Mokar, right? Yes. Trupti, write it here. After putting the values in this equation, how will you go to the next step? So she writes pH is equal to 1.8 into 10 to the power minus 3 plus log concentration is 0.6 upon concentration 0.4. Is it all correct? Correct. I don't know what you people have to say. All agree that this is correct. Ashleisha, correct. Nazum, सही है. माया, सही है. अच्छा, एसिड वर्क बरोबर है. ओके. नाही मी कन्फ्युज आहे. तुझं नाव काय लास्ट वर? हाँ सुजाता. नवीन चेहरा बरोबर. सुजाता सरने वाकचौरे. सुजाता वाकचौरे. करेक्ट है. प्रथमेश करेक्ट. पूजा पारासु करेक्ट. मला काय वाटतं दिस इज नॉट करेक्ट. Good. I like somebody has got the scientific calculator also. बोलिए. नहीं बोलेंगे. अभी तो बोल रही थी आप. See YouTube पे सेलिब्रिटी हो जाओगे 5 मिनट देखना है मेरा. और उसके बाद मेरे सब 300 सब्सक्राइबर है वो भी देखेंगे. नेहा, व्हाट डू यू से? करेक्ट. सब करेक्ट बोल रहे हैं इसलिए करेक्ट ऐसा नहीं. थोड़ा दिमाग लगाओ, कुछ गलती होगी. नहीं दिखाया. हाँ जी. ये वैल्यू किसकी है? 1.8 into 10 to the power minus 3 के वैल्यू है, राइट. आणि ती कुठे लिहिली तुम्ही? पी के च्या ठिकाणी लिहिलेली आहे. आणि पी मीन्स व्हॉट? Negative log. So you will write negative log of 1.8 into 10 to the power minus 3. Please correct it. ठीक है बहुत. Correct. पट्टे वाले प्लस है ना. Okay. So now you have. Okay. See, if you have scientific calculators or even in the mobile you have scientific calculators. If you can please calculate this and come down to something. The correct way of writing pH is not this. P is always small. Okay, so small things that we need to do. So for those on YouTube, we will see what Trupti has done. Trupti has written this. pH is equal to negative log 1.8 into 10 to the power minus 3 plus log 0.6. That is the concentration of the conjugate base upon 0.4 molar concentration of that. Those on YouTube can also try and calculate. They are at home, so they might be having scientific calculators with them. So Adiba is there, Komal Rahane is there, Siddhesh Shetty is there, Renuka is there. सुसंपदा समजता आहे. मी नावं पाठ करतोय. सुजाता. आपने आपका नाम आशा बताया ना? ओके. कोणकोणत्या व्हॅल्यूज कॅल्क्युलेट झाल्या बाय द वे इन द मीन टाइम? 0.6 आणि 0.4 चा लॉग काढणं तर इट्स नॉट अ बिग प्रॉब्लेम. काढला येतं की. This is log. So simple is 0.4 divided by 0.6 is 1.5. 0.6 divided by 0.4 is 1.5. So you take log of 1.5, that is 0.17. So all mobile phones these days have scientific calculators. So this value comes out to be, I'm making it simple because you do not want to waste time, right? So this comes out to be 0.17. Simple. 0.6 upon 0.4 is 1.5, and taking log of 1.5 gives you 0.17. So this is very clear. No. Negative. Oh, negative. No. Anyways, we will not waste time in this. Negative log of 1.8 into 10 to the power minus 3, that will come out to be 4.7. You may continue doing it at home. Negative log of minus that will leave it for this. So this value will come out to be 4.7. This is 0.17. So just add it. So final will be 4.87. So idea of telling you all this is that when you have the concentration of conjugate base, corresponding acid, and pKa values or Ka values, then what you simply can do is calculate the pH of the given solution. And other way around, आता उलट काय करायचं आहे की तुम्हाला जर म्हटलं की एका सोल्युशनचं पीएच 4.87 आहे, त्या ऍसिडचं Ka व्हॅल्यू ही आहे, त्या ऍसिडचं कॉन्सन्ट्रेशन एवढं आहे, तर त्याच्यामध्ये किती बेस टाकू, राईट? And that is the beauty of deciding buffer. Buffer येतात म्हणतात. Buffers are used to keep the pH of a solution constant. एका ठराविक pH आपल्याला मेंटेन करायचा असेल तर buffers are. Buffers are used when you want a certain situation, a certain buffer, a certain working condition. मला एवढं बफर पाहिजे. त्यावेळेला मग तुम्ही काय करणार? So you will change the concentration of the acid and its conjugate base. They adjust so that you can keep the pH at certain level. तुम्ही pH maintain करू शकता. बरोबर? जसं 8 आणि 3 11, 6 आणि 5 11, 7 आणि 4 11, 9 आणि 2 11. So 11 remains same. You want to keep the pH constant. So म्हटलं pH 3 साठी काय करावं लागेल? So you have to change the concentration of these to finally come down to this number. Right? So when you want certain pH, you adjust the concentration of the acids and its conjugate base with respect to, of course, you have your dissociation constants of the acid. This same one, because it is constant, it remains the same. Have you understood this? All right. So you need to add few things as far as the theory is concerned. We also have the applications of the Henderson-Hasselbalch equation. So I dictate few things and you can write it down. Applications of Henderson-Hasselbalch equation. Thank you. There is one alumnus, past student who is a teacher now. He has joined, he or she has joined and is saying that missing our department, sir. But there are other past students also who are listening. Okay, application of Henderson-Hasselbalch equation. The first application is allows to calculate like we have seen in this problem, pH of a buffer solution. This is what we did here. Just now, a buffer solution होता है तो pH अपन calculate किया, found out the pH of the buffer solution 4.87. So allow us to calculate pH of a buffer solution. पहली application which we saw. Second, it shows the proportion of molecules that have been dissociated or have not dissociated. Nustas liu naka, try to understand what I'm telling. Complete dissociation, slow dissociation, half dissociation, right? माझ्याकडे acid is there, CH3COOH. When it dissociates, it will give you acetate ion plus H plus ion. डोक्यात reactions दिसायला लागले ना? It will give you acetate ion and H plus. But I do not know to what extent acetate ions and H plus ions are formed. किती dissociate झाला I do not know. So higher concentration is 0.4 molar, 0.6 molar. Ha, mala andaz deto. This number gives me the idea of how much dissociation has taken place. Correct? So second application of Henderson-Hasselbalch equation is it takes you of the dissociation, the extent of the dissociation that has taken place. Next, that is the third application is allows to calculate the pKa value of a WA, that is weak acid. आता weak acid एवढं मोठं कोण लिहिणार WA, पण तुम्हाला माहित पाहिजे weak acid dash conjugate base pair. Now how? Say imagine in this equation, Henderson-Hasselbalch equation that you have, if you know the pH of the solution, if you know the concentration of conjugate base, if you know the concentration of the acid, what can you calculate? pH. So या जोडीसाठी conjugate base आणि acid साठी you can calculate the pKa value. That is what you have just written. Follow. Next, allows to calculate the ratio of conjugate base to weak acid That means what? This thing. Ratio of conjugate base to weak acid. Ratio म्हणजे प्रमाण, proportion. Conjugate base to weak acid if the pH is given. Given if the pH is given. So if you have pKa, since this is a constant, like for acetic acid we have given, so constant is available to you. If you know the pH of the given solution, then what you can calculate is the ratio of conjugate base to the corresponding acid. Am I right? Right. So this is how some of the applications of Henderson Hasselbalch equation can be utilized. Is this clear with all of you? Okay. Now we'll stop this Henderson Hasselbalch equation and we'll move down to the next part. And the next part is yes. So those who are still not in the habit of having a notebook and writing down, you should have a separate notebook for biochemistry paper that I will be teaching. Like Maya and some other students have done, in the first 2 pages, you should write down the syllabus. Just to encourage you, not because Maya and Pooja are over smart, they came down to my clinic yesterday and they took photograph of the book that they had. माझ्याकडे पुस्तक मी लिहिलेलं त्याचा फोटोग्राफ त्यांनी घेतला ते घेऊन गेले. राईट. आता एथिकली ते करेक्ट नाही. पुस्तकाचे फोटो काढणे कॉपीराईट ब्रीच. या पुस्तकाचे कॉपीराईट माझ्याकडे, माझ्या ऑथर्सकडे आणि प्रशांत पब्लिकेशनकडे. पण ते एज्युकेशन पर्पजसाठी एथिकल पुस्तक छापणार नाही आणि त्यातनं पैसे कमवणार नाही. सो दॅट इज ऑल. म्हणून एज्युकेशनल पर्पजसाठी शी इज डन. दॅट इज ऑल. So now we're moving to the next topic, and that is we will talk about this word which we are repeating time and time again. आपण पुन्हा पुन्हा ज्याचा उच्चार करतो, buffer. What is the definition of buffer? So first thing that you have to correct as far as people at Sangamner or for that matter many other places are concerned, we are in the habit of pronouncing this as definition. आपण याला definition म्हणतो. It is not nation. Definition. All right. Definition. The spelling पण त्यामुळे चुकवतात लोक इथे NATION लिहितात काही. Definition. It is not definition. It is definition. So we'll talk about definition. Concept. What is the concept? Concept. Functions. Types and buffering capacity. Buffering capacity. Not very difficult to understand. If you have studied in chemistry, it will become furthermore easier. Not much difficult. So as I said, if you have to define buffer, it's very simple to define. Buffer is a solution of a weak acid with its salt or a weak base with its salt. So what is important here is this word, one, weak, acid or base. And another important thing is salt. These are the 2 important things one has to understand. What we do mean by being weak. Weak म्हणजे काय? Acid weak कधी असतो? So I have told you already. When the ionization or dissociation does not take place at a higher rate. Strong acid is something which completely dissociates. All H plus ions and all chloride ion get separated. When you talk about weak acid and bases, they do not completely dissociate. That's a dissociation पूर्ण होत नाही. So they are called as weak acids and weak bases. Strong students अभ्यास पूर्ण होतो आणि weak students अभ्यास पूर्ण होत नाही. So all my 15 students sitting over here, nobody is idiot. हे मी नेहमी सांगतो. राईट. सो कालच्या आपल्या प्रोग्राम मध्ये मी बोललो काय there are Gunvanta Vidyarthi. So marks do not decide your intelligence. Marks is just the assessment of how much you had read and what has appeared in the examination. How did you attempt it? That's it. It is not the true judgment of the knowledge. तुम्ही नेमकं जे नव्हतं वाचलं ते परीक्षेत आलं सो मार्क्स कमी आणि नेमकं जे वाचलं होतं यू वर नक्की सो यू गॉट नो मार्क्स. सो स्ट्रॉंग स्टुडंट ज्याने सगळं वाचलं. वीक स्टुडंट मग तुम्ही सर पेपर अवघड गेला. म्हटलं गेला थोडी तुम्ही अवघड करून घेतला कारण तुम्ही अभ्यास पूर्ण नव्हता केला. तर द बेस्ट वे टू गेट मार्क्स सगळं वाचून द्यायचं. काहीच सोडायचं नाही. तुम्ही थोडं हा अवघड होता ऑप्शन मध्ये टाका. So when you put something in option, get a couple. So read everything. That is the idea. That is about knowledge, right? So we'll discuss it some other time. Anyways, so strong आणि weak चा अर्थ समजला. जो completely dissociate होऊ शकत नाही तो weak. मग तो base असो किंवा acid. That is one. But then we are talking about salt also. Salt काय भानगड आहे? Can somebody tell me with your previous knowledge of chemistry when are the salts formed? Salts कधी तयार होतात? Very good, Trupti. So can you write down one neutralization reaction here, a simple neutralization reaction? And yes, Manoj. Trupti झालेली आहे. So Manoj will come. YouTube users, my student Manoj is coming up and writing a neutralization reaction to show me how salts are formed. So acid plus base is equal to salt is what Manoj. Now can you give an example of what acid, what base, and what salt are? Correct. Manoj is absolutely correct. He's saying when acids and bases come together, salt is formed. Good. Although we know very simple examples of acids. Why do you want to go with ions? You know, very simple. Now we are talking about so many acids and bases. Yes. So very simple examples. Our teachers are laws. The job of teacher is to give confidence to the students, make it easier. As soon as I tell one after some examples, I get not as yes, good. Very nice. So things is going right. Okay, correct. Acid is also correct. So he says that acid is HCl and base is NaOH. So go ahead. Okay. Let him do. Baba Ramdev says करने से होता है. So unless and until he is doing, he will not learn. And not going to write, do. Let him do. Let him do. कुबड्या कधी द्यायच्या? कुबड्या दिल्या की तो चालायचा प्रयत्न करतो. लेट हिम वॉक. पडेल, चुकेल, he stand up, he walk again. नाही बरोबर होतं. बरोबर होतं. It was absolutely correct. तू का असं समजतो की माझं चुकतं काहीतरी पण बरोबर नाही ते वरती जे होतं ते बरोबर होतं लिहि पण अगदी बरोबर. You need to do some change here. बस अरे परफेक्ट झालं डन. हाँ एकदम परफेक्ट. सो मनोज इज अ गुड टीचर नाउ. थैंक यू. और ये मनोज पता नहीं कभी क्या क्या बातें कर नहीं गलत की बात जवाब क्या कोई भी किसी ने दिमाग में बना दिया. So Manoj is a brilliant student. Absolutely correct. Even acids and bases they combine together. We have 2 minutes left only for this lecture, so we'll stop here. But just summarizing this. So when acids and bases come together, they react to form something called as salt and water. So the simplest example what Manoj has given, Manoj already told me, and with the help of Trupti, that when HCl and acid combines with a base, strong acid and strong base, so HCl plus NaOH, simple balanced chemical equation that you all know, NaCl and H2O. That's it. So sodium chloride is salt. Right? So heat concept shown. We will meet again in the next lecture that will be on Tuesday. and we'll continue this. How can we make or take an acid, which is a weak acid, for example, acetic acid, take its salt and make a buffer out of it, right? So we'll stop today's session and see you again. Manoj, you had given a paper of attendance yesterday. So take same paper or some other paper and write down the attendance for the day, and we'll stop here. So I'm stopping the YouTube stream also. Take care and join soon for the offline lecture.